Our course theme today is mainly focused on the subject model feature of FineBI. We have 3 goals for today's course. First, we hope to help everyone understand the problems that the subject model solves. Second, we aim to help you learn how to use the subject model and understand the underlying working principles. Third, I will help summarize the business value of the subject model, so that everyone can have a better understanding of this feature. The first part will begin by introducing a scenario of sales performance analysis. Let's first look at how we used to analyze this before the model was introduced, what problems occurred, and how the model easily solves the historical issues we faced. Alright, let's open FineBI and go to the My Analysis section. I have prepared a demo of the subject model for everyone. First, let's take a look at our original table and the content we need to analyze. In our original table, there are 2 tables. The first table is the sales target table. The sales target table refers to the sales goals we set for each year and each month for different categories and subdivisions of products. This table contains the sales target for each month, corresponding to the respective product categories. The other table is what we call the order details table. As the name suggests, this table records the order data. Every day, we have numerous orders, each containing a lot of information, including the corresponding sales amount. This table is designed at a daily level. Alright, next let's see how we used to operate before using the subject model. The operation we need to perform is quite simple. First, we make a copy of the sales details table for backup. Then, we join the sales target table into our order details table. This way, we can analyze the sales performance and how it aligns with the sales targets. Now, I will choose a left join to join the sales target table. After adding it, we need to note that there are 3 key criteria for joining. The first is the category, the second is the subdivision, and the third is the date, since the sales target is based on the year and month dimensions. Here, we can click to create a merge calculation. We use a concatenate function to extract the year and month. Then we copy the formula to perform the same operation on the other table. Now, we have completed a very simple join by using a left join, meaning we have appended the sales target data to our order details data. At this point, we create a new component and name it Direct Join. These are the methods we used previously. As you can see, the data here is complete, with the order details table remaining intact due to the left join. Alright, now we've located the corresponding table. As you can see, through the join, we've combined all the data. Originally, this order details table only had the sales field, but now we have the target sales field added. So, what's the next step? We need to examine the data for different years, categories, and subdivisions. Let's adjust the settings here and expand the row header node so we can fully see the sales target data and our sales figures. Let's make a small adjustment here. Since the data is quite large, let's focus on the data for 2016. We can filter by adding a condition and selecting 2016. Once selected, we'll click Confirm. What we're looking at is the sales for the office supplies segment in 2016, which was 890,000. However, we can see that the target sale is over 40 million, which seems a bit off, suggesting that there might be an issue with the data. So, how can we validate this data? We'll split it into 2 tables. The join operation essentially added the sales target table to the order details table. To validate the sales, we can check the order details table for the sales and check the sales target table for the target sales. Let's start by looking at the order details table. I've already assisted with this, it's the same as before. We can drag the sales field by year, subdivision, and category, then verify if the data is correct. For 2016, the office supplies segment shows sales of $890,000, which matches what we saw earlier. Now, let's check the sales target data, as we were concerned about this. We can see that in 2016, the sales target for office supplies is just over $280,000, whereas the join data showed $40 million. Why is there such a discrepancy? The issue is obvious, the sales target data was copied and inflated significantly. Why did this happen? It's simple. We initially mentioned that the target sales field is set on a monthly basis, whereas the order details are recorded on a daily basis. The two datasets are at different granularities. To understand this better, imagine merging a monthly target directly into a daily recorded table. Each day's data would match the monthly target, leading to inflation, and that's why the numbers are so off. Alright, moving forward, we'll help everyone understand this process through simpler examples. Now, let's return to today's topic, how subject models can solve the issues we just discussed. It's clear that directly joining the data caused problems. So, can models really solve this issue? To create a model, we actually need a primary key. This primary key will help us establish a relationship between the two tables. First, let's add a new column and name it Combined Primary Key. This is similar to the basis for the join. We'll extract the necessary information using functions for the year and month, along with the corresponding subdivision and category. To save time, we can copy this formula for the other table, as we'll need the same thing there. Now, this will be the combined key for the sales target table. Let's save and update it. Now, let's return to the original table, where we'll create a combined primary key by modifying the field names in the formula. After making the adjustments, we can add the column, save, and update it. What we've done so far is at the dataset level. We've edited the tables, added a combined primary key, and used the join function to join the two tables. We're working directly with the original data here. But is the model designed and set up at this level? Of course not. We actually have something called Model View for this. Let's click and enter the Analysis Model View. What is the model view? As you can see, there are many tables here, all of which are tables added to the analysis model. We'll find the two key original tables, one for the sales target and one for the order details. Notice that I've been using the original tables for all operations. Now, let's configure a simple relationship. The system will automatically recognize it. We select the combined primary key. According to the system's recommendation, we choose a one-to-many relationship. You might be unfamiliar with this, but I'll explain it shortly. For now, we've created a small model, linking the sales target table and the order details table via the combined key in a one-to-many relationship. Next, I'll create a component and name it model. Let's compare it. We can now see many tables and fields. Using the drop-down at the top, we can select our newly created model, which includes the sales target and order details tables. Now, the next steps are simple. Just like before, I'll drag the order date and convert it to the year. Next, we'll focus on categories and subdivisions. To clearly view the data, let's set up the table header to expand the rows so we can always see the information. We can look for the target sales data in the sales target table. Let's drag the sales target data in. The sales, however, come from the order details table, so we'll drag the sales from there. We can adjust the order of the fields for clarity and filter to only see data from 2016. Now, you'll notice that the sales for office supplies in 2016 are just over 890,000, and the sales target is around 280,000. Is this correct? Let's review the order details. The 890,000 seems fine for 2016. But is the target data accurate now? Comparing it to the previous join, where the target data was inflated significantly, we can see that the model solved this problem easily. Not only did the model fix this, but we can also do something else, create a calculation field for the achievement rate. This is simply the sales field divided by the corresponding target sales field. We use a sum-agg aggregation function to total the data for a specific dimension. The achievement rate is now displayed, and we can see it clearly. To make it more presentable, let's convert it to a percentage. Now, we can see the achievement rate for different categories and subdivisions in 2016. Some categories have achieved more than 300% of their target, while others have only achieved around 82%. With this model, we can easily compare data and quickly solve the inflation problem that occurred during the direct join. Additionally, we can design cross-table fields within the model to aggregation data from different tables and perform calculations to get the desired indicators. This is what subject models are.